Hey guys, and welcome to another fun and easy machine learning tutorial on k-means clustering algorithm. So today we are playing Call of Duty. Hell yeah! Now for those who have played, you sometimes face some extremely remarkable players, even if you are a novice player. There is a huge gap in skill level when starting out. Now what if an algorithm could help cluster players based on the following skill levels: dismal, intermediate, and remarkable? Please subscribe and click the bell icon to join our notification squad. Now keep in mind, this is different from game-defined experience level, because a person who is skilled when starting out the latest Call of Duty game may have developed his skill from previous first-person shooter games beforehand, whereas a fairly novice person can still be novice even at level 30. So with that out of the way, now there's a whole published paper on predicting skill from gameplay input to first-person shooters. But for now, let's keep it simple and let's use the average number of kills per game versus accuracy. For now, let's look at clustering into two classes, novice and skilled. So over here we have our dataset with our kills per game on x1 axis and accuracy on the x2 axis, our feature vectors. And now we want to cluster this dataset into novice and skilled classes. Empirically, we can see that this cluster having both high accuracy and high kill rate must be skilled players, and this one is the novice one. But let's determine this using k-means clustering algorithm. So the k in k-means is the number of clusters or groups we want to determine. In our case, this is 2 for novice and skilled. So let's drop 2 vectors over here at random. So step 1 is to find all the points in our dataset that are closest to the red and blue classes and label them respectively. We can use Euclidean distance to find which data points are closest to our cluster vectors. An easy way is to draw a perpendicular line at the midpoint between the red and blue cluster centers, and say every data point over the line here belongs to the red group, and similarly for the blue group. Now the next step of the k-means algorithm is to move the center of each cluster to the mean or centroid of all the data points belonging to that cluster, like so. Then we repeat the process, where we draw the line at midpoint and all the points closest to the blue cluster center become blue, and the same for the red cluster center. And boom, you can see our expected clusters emerging. Now we just got one more step of moving our clusters to the mean or centroid of our data points. So we have distinct clusters that we can use to determine whether our Call of Duty player is novice or an expert. Simple, right? We normally iterate until convergence. Now let's look at the flowchart of the k-means to summarize what we did. So first step is we initialize the center of the clusters, then we attribute the closest cluster to each data point, and then set the position of each cluster to the mean of all data points belonging to that cluster. And then we repeat steps 2 to 3 until convergence. So the choice of initial partition can greatly affect the final clusters that result in terms of intercluster and intra-cluster distances and cohesion. So k-means clustering in a nutshell is a traditional simple machine learning algorithm that is trained on a test dataset and is able to classify a new dataset using a k number of predefined clusters. And note, this is an unsupervised machine learning algorithm. So what is clustering? Clustering is the process of partitioning a group of data points into a small number of clusters. For instance, the items in a supermarket are clustered in categories: butter, cheese, milk, and are grouped in dairy products. Of course, this is a qualitative kind of partitioning. A quantitative approach would be to measure the certain features of a product, say the percentage of milk. So products with high percentage of milk will be grouped together. Deciding the number of clusters. The number of clusters should match the data. An incorrect choice of the number of clusters will invalidate the whole process. An empirical way is to find the best number of clusters is to try k-means clustering with a different number of clusters and measure the resulting sum of the squares. The elbow curve. The value of k should be such that even if we increase the value of k from here, the distortion remains constant. This is the ideal value of k for clusters created. So when do we use the k-means clustering? K-means clustering is a fast, robust, and simple algorithm that gives reliable results when datasets are distinct or well separated from each other in a linear fashion. It is best to use when the number of cluster centers is specified due to well-defined list of types shown in the data. However, it is important to keep in mind that k-means clustering algorithm may not perform well if it contains heavily overlapping data. If the Euclidean distance does not measure the underlying factors well, or if the data is noisy or full of outliers. The k-means algorithm defined over here aims at minimizing the objective function, which in this case is the squared error function, where x of I minus c of j is the Euclidean distance between a point x of I and a centroid c of j, iterated over all k points in the ith cluster for all n clusters. Sounds a bit complex? Don't worry about it, it's all handled in our Python libraries. All you have to understand is the intuition that is explained earlier. Let's take a look at the applications of k-means algorithm. Telephone companies use clustering algorithms to place towers so that all its users receive optimum signal strength. Police force uses clustering so that all the patrol vehicles are stationed across the area so that the areas of high crime rates are in the vicinity of the patrol vans. Hospital care chains open a series of emergency care wards while considering accident-prone areas in the region. It can also be used for market segmentation, price spend behaviors, and customer need segmentation, and also mainly used in computer vision. So what are the advantages? Well, with the large number of variables, k-means may be computationally faster than hierarchical clustering if k is small. K-means may produce tighter clusters than hierarchical clustering, especially if the clusters are globular or circular. Looking at the disadvantages of k-means, there is difficulty in comparing quality of the clusters produced. Example, for a different initial partition or values of the k may affect the outcome. Fixed number of clusters can make it difficult to predict what k should be, and does not work well with non-globular clusters, as you can see over here from this diagram. Different initial partitions can lead to different final clusters. It is helpful to rerun the program using the same as well as different k values, and this is to compare the results achieved. This is also known as k-means trap. Be very careful when you set your initial clusters. You can see how the red clusters are invading some of the green clusters because it was initialized close to the other cluster. Check out the website in the link down below to check out an interactive example of k-means algorithm in action. You can see how easy it is to misclassify distinct clusters. Other disadvantages is that k-means algorithm has a strong sensitivity to outliers and noise. It doesn't work well with non-circular cluster shapes, so the number of clusters and initial seed values need to be specified beforehand. And it has a low capability to pass the local optimum. So in conclusion, k-means clustering algorithm is a fast, robust and simple algorithm that gives reliable results when datasets are distinct or well separated from each other in a linear fashion. It is best used when the number of cluster centers is specified due to the well-defined list of types shown in the data. However, it is important to keep in mind that k-means clustering may not perform well if it contains heavily overlapping data, if the Euclidean distances does not measure the underlying factors well, or if the data is noisy or full of outliers, then k-means may not work for you. So that is it from me. Please don't forget to like, subscribe and share. Click that bell icon if you'd like to see more machine learning tutorials, and please don't forget to support us on Patreon. If you'd like to download the script to this video, please click the link down below to download it for free. And please stay tuned to the next lecture where we will see how we can implement a k-means algorithm in Python. Thank you for watching and see you in the next lecture.